For 2.4, our aim is to understand how uncertainty in a measurement arises. So anytime we take a measurement, we're not absolutely certain what that measurement is. So there is a little bit of estimating involved, and that's what we need to look at here, is how we get that little bit of uncertainty when we're taking a measurement. And then the second aim is to learn to indicate a measurement's uncertainty by using what we would call sig figs. So we have to show that we're not absolutely totally certain about the measurement we're taking, and we need to be able to show how we're going to represent that uncertainty. So we need to look at the number, or the word certain, and what it means to be certain about something. We can say that if we're certain, we're sure about it. We're absolutely positive that that's the way that that number behaves, and that that's the number that we're looking at. So in terms of a measurement, a certain number is a number we can see, a number that we can absolutely read off of some sort of measuring device. An uncertain number, just like if we're certain about something, we're sure of it, an uncertain number is something we're unsure about. We're not totally clear on it. We can't necessarily see it. And if we can't see a number, then that means we have to estimate that number. So regardless of whether it's a certain number, one we can see and that we're sure about, or it's an uncertain number, one that we have to estimate because we can't necessarily see it, it's important to remember that all measurements include all certain numbers and only the first uncertain number. We can't estimate out too many digits because we can only estimate that first number that we can't see. So if we look at this piece of equipment, this is a graduated cylinder. It's called a graduated cylinder because it has these little marks, these little white marks on here that are called graduations. So if I'm looking at this mark right here, I am looking for the numbers that I'm certain about. And what I'm certain about is that it's between the number 90 and 100. I'm even more certain that it's between the number 90 and 95. And I can even tell that this mark tells me that it's actually at 94. So I can see the number 94 as a measurement. What I have to do now is estimate any numbers beyond that that I can't see. So I can see that this number is 95. The number the arrow is pointing to is 94, and one below that is 93. So it's somewhere between 93 and 95. The arrow that I've drawn here looks to me like it would be at exactly 94.0. That 0.0 is important because that is the number that I'm estimating. That is the last digit that I'm able to actually estimate. I can't go beyond that because if I'm estimating 94.0, I can't say whether it's 94.02, 94.03, etc. So all I know here is that it's 94 and I'm estimating the 0.0. And don't forget your unit. Numbers are not complete, or measurements are not complete without their units. You need to make sure you have a number and a unit to go with it. And in this case, the unit is given right here. This is a beaker. Again, it has graduations. It's just a slightly different measuring tool. This is more for larger volumes that we don't need to be as certain. So if I'm pointing at this number here, I can see that 60 is here, 80 is here. That means 70 is here. So I know this number is somewhere between 70 and 80. Since there are no graduations between 70 and 80, I don't know for sure what that number is. I know the tens place. I know it's got to be 70 something. What that something is, I have to estimate. I can guess by this. It doesn't look like it's quite halfway, but to me it looks like it's about 74 milliliters. I cannot estimate anything beyond that because I already estimated one digit. After I'm done estimating that one digit, I have to stop with my measurement and then put my unit on the end. And we can see again here that the unit is milliliters. So for this specific arrow, I'm calling this 74 milliliters. What can we say about the accuracy of the beaker versus the graduated cylinder? So looking at these four diagrams, we can really see the difference between accuracy and precision. Accuracy refers to how close we are to the actual value. So when we're looking at this first picture right here, the first two rather, we can see that it's both, the first one is both accurate and precise, because not only have I hit that bullseye, but I've made all of my marks in that bullseye. So accuracy is how close it comes to the actual value. Precision is how many times I'm able to recreate that result. The second one is not accurate because it did not hit that center, that bullseye, but it is precise because all of my values are chunked together. Looking at the other two values, or the other two pictures, I can see that the one on the left is accurate because it's relatively close to the bullseye, but it is not precise because they are not close together. And the fourth one, not accurate because they're not near the bullseye, and not precise because they're not really in the same area at all, or they're not close to each other. So what can we say about the accuracy of the beaker versus the graduated cylinder? If I'm attempting to reach an accurate value or a value close to a known value, the graduated cylinder is going to give me more of an opportunity to do that. The graduated cylinder markings are smaller. I am able to estimate further out to a more precise measurement. So I have a higher chance of being more accurate with the graduated cylinder than I do with the beaker.